Okay, section 2.1 to 2.5 review continued. Calculators still are not allowed. We are now at the free response question that you will have on your exam. Corresponds to number 7 on the test without a calculator. So this one is going to be worth 9 points. Every free response is worth 9 points, so that means I'm going to be looking for things in here in your work and in your graph to illustrate that you know all of these pieces and how to put them on the picture. So the first one, let's just talk about what f of negative 3 exists means. When I grade this, I'm going to look for a y coordinate somewhere on this line, y equals or x equals negative 3. So as long as this vertical line crosses your graph, you would get a point for that. Now if I look at the next one, it says the limit as x approaches negative 3 from both sides is negative 1. So that means buried in this statement here, I have the ordered pair negative 3 comma negative 1. So I can plot that point, negative 3 comma negative 1. And I'm going to put an open circle because limits do not tell me what's happening at the point, it only tells me what's happening near the point. Now if I look at this negative 3, I see that there's no plus or minus up above it. So that means I've got to approach that point from both directions. So I'm going to put little tails on both sides. The next statement says x approaches 0 from the left and the y values are getting close to negative 2. So that means I've got the ordered pair 0, negative 2 hiding in the problem. So 0, negative 2, I go plot it, and I'm approaching it from the left-hand side. Next, I see that f of 0 does not exist. So in order to earn this point, I'm going to look at whatever you've graphed, and a vertical line here should not cross your graph at all. Notice that this hole does not have a point. So right now I have no values sketched that belong to f of 0. So right now, so far, you will have gotten 1, 2, 3 points. Well, actually we don't have this one yet because we haven't put that in yet. We're going to keep reading and make sure it doesn't tell us where to go. So far we'd have 1, 2, 3 points. We don't have the fourth one. Okay, this next statement says the limit as I'm approaching 0 from both sides on f does not exist. So the only way you don't get a two-sided limit is if coming from the left you go to a different place than if you come from the right. So coming from the left we ended at negative 2. That means coming from the right we can end anywhere except negative 2. So I'll just choose this spot and I'm going to come from the right. The next statement says as I'm approaching 3 from both sides, I'm heading up. So this is evidence of a vertical asymptote. So in your paper, I'm going to look for a vertical asymptote, and I'm going to look for two-sided behavior that's heading up. Last, we're looking for the domain to be all real numbers except for 0 or 3. So let's double check. That means if I run a vertical line through the picture, I should have a point everywhere except on the y-axis and on the vertical asymptote. So that means I got to connect everything else in such a way that it is a function so it passes the vertical line test. So I can do something like this. I can go to here. I can connect this and I can continue this off the page. So looking at this picture now, we can see that I have every point except for something at negative 3. So my very last step is to put that f of negative 3 in. It just exists, so it can go in here, it can go outside, it can go above or below. So I'm just going to choose to put a point here. This graph would now get full credit. Let's look at B now. On B we have that same thing. F of 2 exists. So I'm going to look to see if your graph crosses this x equals 2 line. As long as it does, you would get that point. The next thing I look for is the limit as I'm approaching 2 on f of x is 2. That means buried in the problem I have the point 2, 2. And I'm getting to it from both sides. I put tails on the left and tails on the right. Next, I have a statement that says the output that I'm assigning to f of 2 is not the same as the limit. So that means the y-coordinate that goes with 2 cannot be at the place that the limit ended up. So that means I've got to have a point that is not at 2, 2. It could be 2, 4, 2, 5, 2, 7, 2, negative 6, wherever you want it to be. So notice now that this picture right here has already earned me 1, 2, 3 points. I've got a y-coordinate, I have a two-sided limit, and I'm not continuous. Now let's look at the next one. This says as I approach negative 2 from the right-hand side, my outputs are getting close to negative 1. So that means I'm dealing with the point negative 2, negative 1, and I'm approaching it from the right-hand side. The next step says that the two-sided limit as I'm approaching negative 2 does not exist. So coming from the right, I've already figured out it ends up at negative 1. That means coming from the left, I have to go someplace else. So let's go maybe up here. The next step is evidence of a vertical asymptote. I'm approaching 0 from both sides, and my thumbs both need to be going up. So I have a vertical asymptote at x equals 0, and I'm heading up on both sides. The last piece is, can I connect it all in a way that keeps it a function and gives me a domain that's all real numbers except 0. So I've got to get from the edge of the graph to my first leftmost point. Then I have to hop down, and there's my little tail, so I have to start my function on this panel with this point. I'm going to head up to that asymptote. Now this one you might be tempted to go to the point, but that would be incorrect because you've got to get down to this tail of function that is connecting and giving you that limit. And then we continue. So this graph will now earn you all your points. Final one, part C. f of negative 1 does not exist. That means if I drag a vertical line through this, it had better not cross your graph when x is negative 1. The next statement says, as I'm approaching negative 1 from both sides, my outputs, or my y-coordinates, are getting close to 1. So buried in the problem, I've got the point negative 1, 1, and I'm getting there from both sides. So I put a little bit of tail on both sides. Third statement says f of negative 3, or the output, or the y-coordinate that goes with negative 3, is the same as the limit as I'm approaching negative 3 from the left-hand side. So I didn't get any information about what that limit was, so I'm going to keep reading just to make sure. Do I see anything else that talks about the limit as I'm approaching negative 3? Well, here I've got a limit as I'm approaching negative 3, but all I say is that it doesn't exist. This one is not negative 3, this one is not negative 3, so it looks like these two statements alone are enough to tell me what's going on with negative 3, and it doesn't nail it down in a particular place. All it says is that if I approach negative 3 from the left-hand side, so let's put our x-coordinates, say, here. If I'm approaching from the left, I'm going to hit the output, so that means that gets colored in. This statement says that the limit does not exist, so coming from the left toward negative 3, I better be at a different place than coming from the right. Next, it says the limit at 0 does not exist. So coming from the left, we'll just put it here, does not match up with where it goes coming from the right. Last, I've got the limit as I'm approaching 3 from both sides is negative infinity. So again, I have evidence of a vertical asymptote, and this time I'm heading down on both sides. Final step, I've got to connect everything so that I satisfy the conditions stated here. So I've got to start as far left as possible, connect to the far left point. Now I'm going to jump down to here. I've got to connect my next two pieces. Connect, connect, and head off the graph. Now my final step, it says the domain is all real numbers except -1 or 3. So at -1 I don't have a point. That's good. At 3 I don't have a point. But if I look at this graph, it appears that I don't have a point at 0 either. So if I want the domain to be all real numbers except for -1 or 3, I better put a point somewhere on this y-axis. So it doesn't matter where I put it. I can put it here, I can put it here, or I can put it somewhere that's not at either of those places. So let's just put it here. Doesn't matter. We're now done, and we would get all the points for that graph.